So today we're going to do another Code Wars challenge. Let's go ahead and open it up. This one is called Pagination Helper, strengthening your page foo mastery. So we're completing this class. It's a utility class for querying the paging information related to an array of values, and how many items per page. We're going to ignore the types of values in the array. And we've got some methods on this class: page count, item count, page item count, page item count, page index. Okay, so it looks like we're going to be implementing some methods on this pagination helper. So just to start, we definitely want to store the collection and the items per page. It could be that we will do some more initialization here if there's other things that we might want to pre-compute, but at least for now, I'm going to go ahead and leave this way. This is pretty simple. If we've got an array, then we can just return its length. So this collection length, page count, the number of pages. So this is going to be roughly, it's going to be the item count divided by the items per page. And then we need to do a little bit more to figure out to round this to get it into to an integer number. Pages are gonna be like integers in length. That you can't have like a fractional page, and so we need to do something to this. And the thing that we need to do here is round up. So we're gonna do math.ceil. This takes the ceiling of some float. So if we have like 4.5, then that goes to 5. If we have 4.0, then that should go to 4. So that should be the value that we want, the item count divided by the items per page. Page count, page item count. Well, let's actually, before we keep going, let's just go ahead and run the tests just to see. Okay, so it's not testing these two methods because they are too simple. So I'm going to, we didn't get any information from this. It only ran these two tests for the, maybe it ran more tests, but then it only failed when we hit to the page item count. Okay, so that's actually good. It did test the page count and the item count, and it looked right according to the tests. So page item count is the next thing we have to implement. And I didn't quite understand what this meant, so let's reread this. Returns the number of items on the current page. So page index is 0 based. This method should return -1 for page index values that are out of the range. Okay, so for a given page, given by this page index, it returns how many items are on this page. So just thinking it through, if you're thinking about like most of the pages that we actually care about in the collection, it should be like usually this is this dot items per page in like the pages that we mostly care about. But there's a couple special cases. So it looks like if there is a page index that is out of range, if the page index is out of the range, so that's less than or greater than the, so less than 0 or greater than the number of pages, then we're going to return -1. And then the final one that we actually have to worry about is the page item count for the last page. So if we get to the sort of that final page in the collection, then it could be less than the number of items per page. It's like that page might only have some items. So for the final page, it's going to be something. I think we'll probably get away with using the modulo operator based on it's like this dot collection length modulo the items per page. This is like how far past the number of items per page did we spill over on that last page. So I'm just going to do this with ifs. So if the page index is less than 0, or the page index is greater than this dot page count, then we're going to return -1. Then we're going to handle these sort of all out of I guess it's this is the order. So if we're out of range, early return -1. Otherwise, we want to test for this final page, and I'm very likely to get these things off by 1. It's like I'm gonna rely on the test to catch me if I'm off by 1 in one of these things, or I could be off by 1 in this as I'm writing it. So the final page is when the page index equals the page count. Now it could be that I need a -1 on this or on this or both. So I could be that I'll end up coming back to this, but let's go with this for now, and then we'll run into the issue when we run the tests. So we want to return this this result here. So just thinking through this again, say that the page size is 5 and we've got 12 items, then 12 items in the collection, then 12 mod 5 is 2, which is how many items there are gonna be on the last page. Yeah, the page item count for the last page is basically the same as what the modulo operator, like that's sort of what it does. Okay, so if we're not on the last page, and if we're not out of the range, then we're just on a normal page, and we can return this dot items per page. Okay, I'm going to run the tests, and we'll find out whether or not I'm off by 1 or not. Let's go ahead and run the tests. Page item count 2 expected 10 to equal 4. Page item count 2 expected 10 to equal 4. Page item count 4. Okay, so we've got, this is our collection. There's 24 items with 10 per page. And we are testing page item count. I guess this is the index and this is the expected value. This test framework here is a little bit wonky. So I think we're testing page 2 of this index here. Sorry, page 2 of this collection here. And we should get 4, but we're getting 10. So we're getting 10 because we're hitting this. This is the items per page, and that's how many items per page we're getting. And we should be getting 4, which is this, is like the result of this modulo operator. So I think page index is, yeah, I think I'm off by 1. This is the result here. So let's try fixing this up by one error. Okay, let's just run the test again. Okay, that did fix the page item count tests, and so now we've got the page index is 0. Yeah, okay, so great. So now we need to implement page index. Determines what page an item is on, zero-based indices. This method should return -1 for item index values that are out of range. Okay, so we've got a couple of cases here again. So item index is out of range, we should return -1, and then otherwise we should determine the page for a given index. So first let's handle this out of range. So if the item index is less than 0, or the item index is greater than, I'm guessing that we're 0 indexed here again. Yeah, zero-based indexes. If the item index is greater than this dot, we'll just use item count. Then we're going to return -1. And otherwise, we're going to figure out what to return here. So what page an item is on. So what page is an item on? Let's first just run the tests. I think this first one should work now. Cool. And so now we are in this case that we don't know how to do it. Okay. So if there are 24 items and we get asked for item with index 7, it should be on page 1. So this is the item index, and so the item index divided by the items per page is going to be sort of roughly what this is. And then we're going to have to do some rounding again. So if we've got item 55 and we've got 10 items per page, it's going to be like on page 6, which is index 5. So let's take the floor of this. And that's what we'll run our return. Let's run the test and see if that gets it. Cool, yeah. So that was just sort of reasoning it out and trying to do the math. I am going to leave the comments in place and just go ahead and submit. There's probably some cleanup that we could do to make the comments a little bit clearer. Number of items, yeah, it's doesn't really returns the page count returns the number of pages. Yeah, not shocking. Let's remove that comment. I don't think it's helping. Okay. I think this comment is actually at least marginally helpful, mostly indicating that it's zero-based and that it returns -1 under these circumstances. Yeah, I think those are helpful. Also moderately helpful. Cool. Let's go ahead and hit the attempt button. This runs the full set of tests. Oh no, we have got something wrong. For item count 3 and items per page 3, we expect page item count of 0 to equal 3. Page item count 0 to equal 3. So if okay, so we've got maybe we've got another failing test. Page item count 3 for page 2. Item count 8. So we've got 8 items, and then there are 2 per page, and we're trying to find out the number of items on the current page. So that's this number. Okay, so I think what's happening, if the final page is full, so we've got 2 items on the last page because the item count is divisible by this. So there's 2 items, and the items per page, like the limit is 2. Then this is returning 0, but that's wrong because there are actually 2 items on that page. Yeah, we're looking for the last page of a collection where the okay. So we sort of have to detect this particular scenario. So the modulo operator isn't perfectly aligned to what we want here. We really want something that is not quite the modulo operator. We want it to be items per page. If this is basically if this is 0. So I'm just gonna sort of hackily do this. Let the result be this, and if the results is 0, then we could return this items per page. And then otherwise we're returning the result. So this will pass the tests, I think. Now I'm guessing that there's some more clever way to do this, to count the number of items on the last page. Yeah. I tried to do this clever math trick with modulo, and now I'm not sure if there's like a better math trick to use, or if I don't have a good answer here. I'm gonna go ahead and just leave my hacky answer, and then I'm guessing that in the other solutions we'll see something clever to do with this. Last page, so I'll add the comment. Is slightly tricky if the number of items, if the okay is the page count. So let's just leave that note right there, and so we're saved here because we have done this check. If we hadn't had this check here to confirm that we're not out of range and we're on the last page of the collection, then this would certainly be wrong. At least I'm pretty sure it would be wrong. In this world, we want this sort of funky result, which is it's not quite the mod. We want the mod, but also we want the items per page if the mod was 0, if it was divisible by that length. So let's go ahead, and I think we have to hit submit again, or attempt again, because we made some changes, and then we can hit submit. Let's see the other. Okay, so people are writing it with a prototype. This is just like the other way to write JavaScript methods, and just using the prototype instead of the class syntax. Page item count, return -1. So this is another way to do that same little trick that I did, which was, so this is the item count minus, okay, so they take the floor of this times the number of items per page. Yeah, that seems like another way to calculate this. That's maybe a little cleaner than my modulo solution. I don't know. Yeah, maybe better. Format. Yeesh. Maybe this is for like dumping it out. Format. Yeah, unclear why they're format.length. Okay, so they're doing the calculation here. So this is okay. So this is stepping by the number of items per page. This is building up. I hate that. I really, it's like they're doing the pre-calculation, but they're calling it this weird name, and yeah, I don't know why they're doing it this way. This is, to me, format. Ugh. This is to actually like do the pagination, but they're doing it not actually as a pre-computation. It's just like another method that is available. This is my least favorite to look at. Just the naming is so bad. It's not. It's actually like it's clever. They create all of the pages with all of the slices of the collection. So it's like it's actually not a bad way to do things. Just like the organization of it is gross to me. Okay. This is a very hacky way of doing the. I guess they don't know about math.ceil. That's too bad. And this is whatever 200 characters wide because I forgot how to format code. Oh well. Interesting that this doesn't even save the collection. It just saves the item count. Actually, kind of like that. We don't need the collection itself, and so we don't save it. Page count minus math dot. Why are we doing funky stuff with the negative here? I don't really get that. Why are we subtracting? It seems like maybe they also don't know about math.ceiling. I think that the floor of the negative of something is going to be the ceiling, but then they have to take another negative. They have to do the double negation so that they get back to the positive. That seems galaxy brained to me. Just take the ceiling. Okay, math.min, items per page, items count minus page index times items per page. This is probably the nice thing that I missed when I was looking for that solution. So item count minus page index times this stuff, items per page. Yeah, this is the thing that I got all wound up about in my searching for the modulo solution. This is sitting right here. Anything else that's clever in these solutions? This is maybe a cleaner version of mine. Well, I don't know. whoa. This is really horrible looking. I'm sort of amazed that this works, given the way this code looks. I'm just not even going to bother reading it. Okay. Yeah, this looks. Is this my solution? This is somebody else's solution, but it looks very similar to mine. I did something better than mine for the page item count. Okay, that's enough. Interesting little problem. Yeah, counting things gets a little hairy. Glad that I had the tests.